So welcome to the second session. Before we start second session, let me just clarify that today our focus is going to be on some technical issues of econometrics, particularly which we regularly encounter, like data. Lots of students yesterday had questions on data, whether we can apply econometrics on primary data. If so, what are the conditions, etc., etc. So today we are going to focus on those data types and also where we can use and what are the issues which comes when we are using that kind of data. So we should start from this point that yesterday we left and we discussed few fundamental issues of econometrics where we identified 2-3 core aspects. Number one, first was that philosophy is integral to econometrics. And therefore, you need to have some philosophical background to understand the dimensions of a research problem. If you're not able to understand the dimensions of a research problem, then you're not able to apply properly and answer the questions properly. So you will always be in a dilemma of deduction or induction. So for that, you need to have some background of philosophy which is used or which may be used in statistical or econometric analysis. For that, we have a latest book. It is known as the Oxford Handbook of Philosophy of Economics. This is a book by Oxford, the Oxford Handbook of Philosophy of Economics. Now, generally, what after the title, even if you are in a book fair and you pick up this book with the title, you will expect to be lots of philosophy in that. But you know, if I read the contents for you, the first part is all about, for example, if you can see, first part is all about laws, causation, and economic methodology. If economics is a science, what kind of science is it? Okay, realism about unrealistic models. So you know, models, mathematics is now coming into philosophy. So just don't go with the title. We have very limited understanding of philosophy. So that is what I was talking about. You have rationality, experimental investigation, dynamic modeling, all this computational economics, causality, invariance, and policy, all is coming into this. This is one of the latest book. Again, I showed to you the Oxford Handbook of Economics. Okay. Then and then causality. We have a specific book on causality also. This is a book by the title The Book of Why. Okay, The Book of Why, The New Science of Cause and Effect by Jude Ford. He also has written one other book by the title Causality, but it's not that much popular. This is one of the popular books. So this is also a recent book, I think published in last 2 to 3 years. Let me check. So it is published in 2018. Okay. So it is the latest book on causality that also you can read. So this is from my portion. This is the suggestions of the books which I am telling you. And these are some latest books and books which are by established writers and which are very easy to understand if you can understand English language easily. Now move on to our today's discussion, which is going to be very technical and a bit complex in nature, but I'll try to make it simplify for you. So today we start the second session of our econometrics workshop. We have data types in econometrics. This is our today's discussion. And the punchline I have selected for today is with big data comes big problems. So sometimes we see that if we are not getting data, if data is not available to us, or we have to generate our own data, we see that as a problem. Indeed, that is a problem. But when, at another level, we have a different problem. The problem is if we have big data means we have lots of observation. Then we also have a problem because with big data is coming lots of big problems of analysis and understanding that data, understanding the features and the characteristics of data, etc. We have nature of numbers, we have laws of numbers, we have laws of data, and that we need to understand. If you go to statistics, there you have the types of data generally understood as the nominal data, the ordinal data, the interval data, and the ratio data. And this is very important for all of us to understand that this classification of nominal, ordinal, interval, and ratio is also very important. When we talk about data in econometrics, we consider these four parameters as well, but we talk about how the data is being presented and then how it will be analyzed. For example, today's session, I want to make it more interactive so that we are able to discuss and then understand, and a bit less formal in nature. So let's come on to the question of what is this nominal, ordinal, interval, and ratio data? Can any one of you just come up with this answers on nominal, ordinal, interval, and ratio data? You can raise your hands now, and I can invite you on the panel to just discuss with us what is this data. Anybody can raise your hands just to discuss. Okay, Mazhar Alam is raising hand. Let's take him on the panel to talk about what is this nominal data, ordinal data, interval data, and ratio data, how to create a difference between these. Yes, Mazhar, can you hear me? Mazhar, can you hear me?
Hello.
Hello, Mazhar, can you hear me?
Hello.
Hello, yes, Mazhar, we can hear you. Yes, give your inputs on data types in statistics like nominal data, ordinal data, interval data, and ratio data. Hello, can you hear me, Mazhar?
Assalamu alaikum.
Okay, he is not responding. Islam, can you be very quick in answering the question? What is the difference between nominal, ordinal, interval, and ratio data? He is not able to answer. Let's go back. We don't want to waste any time. If anybody else wants to come up with the answer, they can raise the hand and then I can take them on the panel, or otherwise I will come up with the answers. So you will get lots of simple answers about what is nominal data. It is related to name. Okay, we have Muhammad. Somebody wants to ask. Let's take him to the panel. Yes, Muhammad Samrud. Yes, Samrud. Come up with your answers. Samrud, can you hear me? Samrud, can you hear me?
Yes, sir. I can hear you.
Yes, sir. So
Hello.
what is your answer on? Yes, what is your answer on these types of data: nominal, ordinal, interval, and ratio?
The nominal, we use it for a mere identification purpose.
For example,
Roll number of students, or
okay. Then second, ordinal data.
Ordinal, the data will be having an order. It can be ascending, descending. There will be an order,
Okay. Then third, interval data.
Interval will also be having means it will be having an equal distance between in between the points. There will be equal distance also will be there.
Okay. And then ratio data.
Ratio, there will be the presence of an absolute zero will be there.
What do you mean by absolute zero?
Sorry, there will be an origin.
It's quite difficult. What is origin? I'm not able to understand. And for audience, let's make it very simple.
Like it starts from, for example,
Okay, okay,
in
okay,
uh,
okay, okay. Okay, thank you. So I'll just come up
okay,
with the answers. Thank you, Samrat, for your answers. Now,
okay,
you see, when in statistics we have these types of data, nominal, order. Generally, this is what we are taught. That nominal data is where we have some identification, for example, name, gender, absolutely correct. But this definition, these definitions or these explanations are problematic for us to understand. Like for example, nominal is easy for us to understand because we say that okay, it is for only identification. For example, the demographic features, whether you are, for example, gender, uh, for example, nationality, for example, uh, regional characteristics. Now these are in language terms, and these are some identification, and these cannot be represented in mathematical form, and even if in mathematical form, then they have no mathematical value. Okay, so this is nominal, so it's quite easy to understand. But when it comes to all the rest of the three, the ordinal, the interval, then and ratio, it is very closely intertwined. So then we need to have some conceptual understanding. And this is the problem of measurement of data, how to measure things. You know, in the real world, we have very few things which can be measured absolutely. Let's take the example of the value of money. Value of money is relative. It is not an absolute value. And sometimes we have measurement criteria which are very peculiar. I'll just give you a question and then I will ask answers from you. For example, uh, can length, length is one of the criteria of measurement. Can length be used to measure body temperature? This is my question to you. You can answer this question by raising a hand. Two, three people who are ready to answer this question. Can length be used to measure thermometer? It means, can it be used to measure the body temperature? Anyone of you? Very quickly, very quickly. I want today's session to be interactive but very quick. Yes. Anybody? Nobody is raising hand. Next 5 seconds more. If anybody wants to raise hand and answer this question very quickly. Can length be used to measure body temperature? Nobody is ready to answer that. No, we can't. Aksanjan is showing no, we can't measure. Anybody else? Just come up with your answer in chat box. If you do not want to come on the panel, just very quickly answer. No. Kamlesh is also saying no. No, we can't measure. Hemant is also saying no. Others, I am waiting for your answer. Mariam is saying no. Anybody else? Next 5 seconds. Be quick in answering. This can length be used to measure body temperature? Fayaz, no. Shujat Naeem is saying yes. No, we can't. So, Shujat, can you give your explanation? Should I take you on panel? Let's take Shujat on panel and see what he's saying. I am taking Shujat on the panel. Others can answer. Anshu is also saying yes. Let's hear from Shujat. Shujat first what he's trying to say when he's saying that yes, length can be used to measure body temperature. Yes, Shujat. Yes, Shujat. Yes, your answer.
Yes, it can be used to measure temperature because that is what we do on a thermometer, right?
That's correct. That's the correct answer. Absolutely correct. Now you can see this is the correct answer, that we are using length to measure body temperature, and this is not the absolute. Thank you, Shujat, so much. So there were few people who were able to decipher this question, and through this I want to inform you that this is the issue of measurement. This is the problem of measuring things, that we sometimes do not see things how they are measured. We see that we assume that things are measured in a very deterministic manner, but there are loopholes in measurement criteria. You know, the differences in time, measuring of the time, therefore we have different time zones. You know, length is used in measuring body temperature. In thermometer, what it happens when mercury covers a particular distance, which is actually length. then we say, okay, this much is the body temperature. It is not the absolute measurement of the body temperature. And measurement is also a problem. For example, how we measure a cloth, or for example, okay, how we measure a cloth by meter, by length, but this is only one of the characteristic of measuring cloth. There are other measurement criteria of cloth. For example, quality is another measurement criteria. For example, the material used is one of the criteria. How much content of cotton is there in a particular cloth, that is also another criteria. So we have lots of criteria of measurement, and measurement is a very problematic issue. And therefore, this measurement leads us to this scaling, and these scaling are not absolute. So we have, from statistical and econometrics point of view, we have these four types of data, and where in two data we can have mathematical analysis, and in three we can have mathematical analysis. But apart from those three, we cannot have any mathematical analysis. So in that case, we need to focus on what those differences are. So if you start from the extreme, from ratio, the ratio data allows all the mathematical calculations, and it is logical to have all the mathematical calculation of ratio data. For example, most of the economic data is ratio data, which means you can have all the mathematical calculation of ratio data. Okay, so for example, money, you have 10,000, your income is, when it is measured, it is in ratio data. Why? Because it can have all the mathematical functions applied to it: division, multiplication, subtraction, addition. You come to the next one, that is the interval data. Now in interval data, you have some differences between two position, 2 point of time, or any two position, or any two points. That is what is the interval data. But in interval data, all mathematical functions are not allowed. So you can have subtraction and addition, but multiplication and division is not possible. So for example, in interval, for example, time. So differences between, if you have two events which are parted by 1 hour, you can have additions on it, but you cannot have multiplication on it. You cannot have division on it. And then similarly, you have the ordinal data, where you are just ordering. Now suppose I am asking you to order on a scale of 5 brands. So you are ordering 1, 2, 3, 4, 5. Now this 1, 2, 3, 4, 5 is indicating, which is incorrect indication, that the difference between these 5 brands is equal. 1, 2, 3, 4, 5. It means if I'm saying 1 to Levi's, and second to Wrangler, and third to say Nike, it means that the difference of my choice between Wrangler and Nike and Wrangler and Levi's is same according to this scaling. But actually it is not, because the question has not been posed about the quantification of the differences in the like. So here mathematical calculations are not possible. So this is where the differences come in statistically. Okay. Maria is answering that, okay, in ordinal we know that A is bigger than B, but how bigger we don't know. That's correct. We don't know. For this we need more interval and ratio. Correct. So this is what is the fundamental types of data in statistics. And econometrics do not start from here. Econometrics assume that you have knowledge and you have a fundamental understanding of these data types, because in econometrics we use most of the economic data, and economic data is ratio data. So the question of posing issues on it doesn't arise. But we have in econometrics the concept of dummy variables, which are characteristic data. So in that case, we have some issues which we are not taking today, but that comes under the dummy variables when we are taking some issues. So let's move on to our discussion. So we are going to start the data types in econometrics, which starts with the different types of data. So we have the first type of data, which is the cross-sectional data. Okay, It is the data which is collected at a given point of time. So if I say that today I'm going to measure the income of all those people who are living in my locality today, it is given at any given point of time. If we are measuring anything, the data which is generated by measuring at any given point of time is cross-sectional data. How you can remember that what is cross-sectional data? We have here cross sections means we have different units of observation, but they are emerging out of single point of time. That is what cross sections is. Okay, so this is what cross sectional data is. For cross sectional data, generally you require random sampling, because in order to have features in cross-sectional data and to have a bolstered and very strong data type, we need random sampling. Now, random sampling is a very difficult issue, and it is a very comprehensive term. It's not easy to make people understand what a random sampling is. But ordering of data according to time does not matter, because it is just one point of time. Therefore, here you cannot order the data according to time. So here it is, for example, in 1991. Now this point doesn't mean that it is just one moment. It can be a day. It can be a month as one point of time. It can be a year as one point of time. But you will have one observation to come into that only once. So suppose I am one of the respondents and the time frame of data collection is January 2020. I will be counted only once. So this is one point of time is January where my data is being collected, but data is collected from me only once. So it is a cross-sectional data. So time, this should not be restricted to a moment. It can be a month, it can be a year, it can be more than a year. But if there is no repetition of this observations or sampling units, then it is cross-sectional data. If there is repetition, then it is not. So we have an example of it, how we can understand. So now see, we have observations starting from 1 to 400. And we have all the variables, wages, education, experience, whether female or male, and we have marriage, whether married or unmarried. So here we see that this data has been collected at a point of time. Because here repetition is not there. We only know that these are the respondent and their variables has been, data according to the variables has been collected. And it is because at a specific point of time, therefore it is a cross-sectional data. Yesterday we were having discussion whether econometrics can be used for primary data or secondary data. If primary data, what kind of a, this is one of the very simple examples of primary data, where you are collecting a data and you are extending that data to be collected only at one point of time, where you are not repeating the samples. This is a classical example of data being collected from a primary research, from a primary survey, and then you can go analyze. This has utility in econometrics. So if you are a researcher who is involved in data collection, then you have your data set, which is a cross-sectional data if samples are not being repeated. And then you can apply all of the techniques which are mentioned in econometrics under the cross-sectional techniques of econometrics. Before I move forward, I just got reminded to share one more book with you which talks about data types and which is very important to understand the logic of numbers in econometrics. The title of the book is A Mathematical Approach to Logic. It is quite a difficult book, but if you even read the brief opening chapters, you will be able to understand. A Mathematical Introduction to Logic. People keep talking about logic, but seldom do we read what actually logic is. Okay, so because of that, people do not understand measurement and do not understand the different types of data. It can be very confusing to them sometimes. So I would recommend you to read this book. So this is what a cross-sectional data type is. Moving on to the next type of data, we have the next data type as, okay, we have another example. So you see another example is, we have observation again from 1 to 50. we have countries, and we have the variables for them. The GDP we have government consumption as percent of GDP, and then we have secondary education. Now here, if this type of data is shown to you, you may get confused. But here nothing is new. Only one thing is new, that we here sampling units instead of respondents are countries. We do not have respondents over here, but we have countries over here. And because we have countries over here, that's why what is important is that it still remains a cross-sectional data, because Brazil is coming only once in this data, Russia is coming only once in this data, India is coming only once in this data, and no specific time is mentioned. It means this data has been collected at a very specific point of time. Therefore, this data again falls under the category of cross-sectional data. So for us, the terms are not important. We need to see whether there is a repetition of samples or not. If there is repetition of sampling units of respondents within the same data set, then it is not cross-sectional. So because here Brazil is not repeated again, Russia is not repeated again, India is not repeated again, China is not repeated again, therefore it is also cross-sectional data. Clear? Then time series data. Here I will just take a pause and I will ask you that if you have any question related to cross-sectional data, you can post your questions, or we can take the questions later on. Few people are raising their hands. Let me see what issue they are facing. I will just invite them. So we have Sayyid Muhammad Abbas, who wants to say something. Let's take him to the panel and see what his concern is. Yes,
निकाल के
Abbas,
अपना 2-4 हज़ार रुपया दे दिया जाए
yes, Abbas,
तभी
you want to
वो
add something? You want to add something?
बिल्कुल बिल्कुल जी 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 हाँ, हाँ।
Okay, sorry, sir. Yes. So we can see that Anushi Singh is saying that she has made me questions. You can put your questions on this particular chat box, and you can we can then discuss those questions. And so now coming back to the next data type, let's come back to the next data type. Okay, the time series data, which is actually a very powerful data. Why powerful? Because time is very important. If you see recently, Elsevier has come up with one of call for paper on time as a constraint of doing research. Is what role time plays. If I just see if I'll be able to get that, I'll share it with you. And I'm writing for that. So time is a very important constraint, not just in our lives, but in analysis. And as you have more and more time, which means if you have data which is spread across time, it becomes more powerful to give you better results and forecasts. So why we have this term experienced people? Somebody who has spent some time in a particular organization, we call them experienced. Why? Because time has value. So investing time in a particular study, branch, discipline, profession to give return and recognition. And the reason is we all believe, and there is also sufficient evidence for us to believe that with times comes power and determination. So that also applies in econometrics. So time series data is one of the most powerful data, and that's why you will see most of the economic data is a time series data. In time series data, we have two philosophical concepts of lag and lead. And you will be sometimes you will be surprised to hear one of the assumptions of this time series data which you after hearing you will see it's very simple, but we have never thought about it. And that is whole concept of time series analysis. So these are two concepts, that is lag and lead. Lag means, for example, the 1991 new economic policy, just a hypothetical case we take. The 1991 new economic policy, we assume that it will have an impact on 1992, 1993, 1994. It can also have impact on 2010. It's not something uncommon. This is the concept of lags. So if I want to say that today's economic prosperity of the country is because of what? So I have to use the concept of lag. It's not just whatever happened 50 years back. It is a consecutive process. And this consecutive process has lags into it. And therefore, these lags are important for us to understand. So lag means going back. And whenever we go back, for every one back step, we have another back step. And each of the back steps are related to each other. This is what the concept of lag is. And lead is going into future. This is what is the lead which we use in forecast. So the lag, going into the past, and lead are very important concepts in time series data. Now, time series data and its analysis depends on the philosophy that past events can influence future events. If you do not believe in that, then the whole concept of forecasting will shatter. So that's why Nassim Nicholas Taleb has said, and I quote, forecasting is very dangerous, especially when it is about future. Now you see, forecasting is all about future, but this is a very oxymoron statement, where it is a contradictory statement, where he's saying that forecasting is a very difficult task, especially when it is about future, when we know that forecasting is all about future. So the important issue is that if we do not believe in this philosophy that past events can influence future, then we cannot go for forecasting. In order to go for forecasting, we have to believe in this statement. So this is the philosophy of this. If any philosopher in the future or in the past comes up with an argument challenging this particular statement, then the whole concept of forecasting will shatter. What are the major problem in time series data? The major problem in time series data that the data is not stationary. Now we have not discussed stationarity, but in simple terms, stationarity means the data is somehow unstable. The data needs to be first of all stable in order to be used for forecasting, but it is unstable. So we say if there is, if the data is stationary, it is stable and it can be used for forecasting and drawing inference. If it is unstationary, it is unstable. We cannot use the data type to draw inferences or to forecast in the future. Let's take an example of time series. Now we have this an example of time series. We have lots of time frames. It can be number of days, day 1, day 2, day 3, day 4, day 5, day 10. It can be weeks, week 1, week 2, week 3, week 52. If it is a leap year, week 53. We can have years, 1951, 52, 53. We have years and we have observation for the years. But now for every year, we have one observation. This is time series data. Every year, one observation, time series data. So we have time, but lots of time frames are there. But observation for each time frame is one. And we can have multiple variables. This is what a time series data is. So the data, how you can remember, the data of most of the economic series is time series. For example, GDP, foreign exchange rate, inflation rates, because they are spread over time frames. And for one time frame, we have one data. So exports, imports, all these are basically time series data. Okay, then we have another data type, the pooled cross-sectional. It means it is cross-sectional is mentioned over here. It means it has properties of cross-sectional data. And then pooled data, so we will see how it becomes a pooled data. So pooled cross-sectional is equal to cross-sectional plus time series. Okay, so this is a simple way of understanding. If you combine both, it means what? that in cross-sectional we had one observation, we have observations for one specific time period. And in time series, we had one observation for different time period. If you combine this, what you get, you have multiple time frames. And for each time frame, instead of having one observation, you have multiple observations. So this becomes a pooled cross-sectional data. So an effective data used to analyze the effect of a new government policy. This is an example where we have time series as well as we have the cross-sectional. It consists of the property of both cross-sectional and time series. Unfortunately, today we are not discussing the properties of these data types because we have to discuss some other fundamental issues. But you can go on and read about the properties of cross-sectional data and properties of time series data. How to understand it? So somebody is raising a hand. Let's go back to some questions and then we can move on. So we have one question by Anshu Singh. My question is how we can use econometrics for cluster analysis and financial research, because large data covered in finance. So please tell me the ways I use it without any mistakes. So Anshu, we can take this question at the end. So Kiran Kumari lagged me, something left behind. Okay, panel data and pool cross-section data same. We'll come to that. No, panel data and pool cross-section, there's some differences. And we have then hi to all. Okay, so no issues are there. So go back to our discussion. Okay. So we have this example. Now see, you see the issues in it. Okay. You see here. So we have observation. Now you see observations and then you have years. How many years you have? 1993. One time epoch, 1995. In between we have 1994. Two time epoch. So we have more than one time frame. So it has a characteristic of time series. Variables are irrelevant for us to decide whether it is time series or cross-sectional data. So it has a property of time series because lots of time frames are there, 1993, 94, 95, at least 3 years are there, which is more than one. Then we have observation. If you see observation, so for 1993, at one time epoch, we have 250 observation. Then for 1995, starting from 251 to 500, again we have 250 observation. So this property is of cross-sectional. So in this data type, we have properties of both cross-section, because for one specific time frame, that is 1993, we have 250 observation and repetition is not there. But we also have the feature of time series where we have more than one time frames and corresponding data is there. So because it has both the features of cross-section and the time series, it becomes pooled cross-section data. Correct? So with this, we have discussed three data types: cross-sectional data, time series data, and pooled cross-section data. Now come on to the another issue, another slide where we will discuss the next type of data set. And the question which was popping up. Now we have the panel data. So somebody was asking the question that is there any difference between panel data and pooled cross-section? Yes, there is a difference between panel data and pooled cross-section data. Repetition of observation is the difference. Let's go with that. We have a set which consists of the time series for each cross-sectional member in the data set. Also known as longitudinal data, it will be easy for us to directly jump on to this example to see what it is actually happening. Now, if in the previous data set, if you see, we identify the characteristic of cross-sectional and characteristic of time series. Here, if you see, you find that we have observation starting from 1 to 300. That's fine. We have year 1986 to 1990. Then again 1986 to 1990. Then again 96 to 1990. Let's say 2 years, 1986, 90. So we have two time epochs, 1986, 1990. In 1986, we have observation 1. In 1990, we have observation 2. Correct? So till here, this data set, till observation 1 and 2, this data set has the property of cross section and time series. So if you take this data set till this position, till here, if you take this data set only till here, let's draw a line. Till here, if you take the data set, till here it is fine that it is a pooled cross-sectional data because it has element of time series 1986, 1992 years are there, and it has every year has corresponding observation. So it is basically pooled cross-section. But if you go beyond that, then the same trend of pooled cross-section is then repeated again and again with more number of sample units. So we have city 1 with this. Then we have city 2. And similarly, we have 150 cities on which this pooled cross-sectional data has been repeated again and again. So what we conclude from here is that when pooled cross-section data is repeated on other sampling units, then it becomes a pooled a panel data, where it is repeated on different. So we have here a pooled cross-section data, which is for city 1, which is for city 2, which is for city 3, which is for, so independently you can see that for independently for city 1, suppose city 1 New Delhi, independently we have one pooled cross-sectional data for New Delhi, we have one pooled cross-sectional data for Mumbai, we have one pooled cross-sectional data for Hyderabad, we have one pooled cross-section for Nainital, we have one pooled cross-section data for Aligarh. If we combine all these 5, then we will get panel data, which takes us to the conclusion that panel data is a combination of several pooled cross-sectional data. So initially we had cross-sectional data and we have time series data. You club together, you had pooled cross-sectional data. Then if you have more such pooled cross-sectional data, it means pooled cross-sectional data 1 plus pooled cross-sectional data 2 plus pooled cross-sectional data 3 plus pooled cross-sectional data 4, then you have panel data. So this is the mechanism how it is going. Again, I repeat to make it a bit simple for you. We have cross-sectional data, we have time series data. Cross-sectional plus time series, we have pooled cross-sectional data. Then pooled cross-sectional data plus another pooled cross-sectional data plus another pooled cross-sectional data is panel data. This is what a panel data is. So we have discussed 4 data types in econometrics. That is cross-sectional data, that is time series data, that is this panel data, and pooled cross-sectional data and panel data. So we have 4 data types in econometrics, and for all these 4 data types we have different means techniques and mechanisms through which we can apply and reach to a particular conclusion. So that we need to take care of whenever we are trying to understand or apply econometrics according to the data types. So let's see if we have some questions. Will there be a repetition of sampling in time series data? No, there will not be repetition of sampling. So you have GDP, you have number of years. 1991 GDP. Now in 1991, you can have only one figure of GDP. 1992 GDP, only one figure. 1993 GDP only. So sample will not be repeated again and again. Okay, let's see. There are people who are raising hand. We have Sana. Sana, I'll take you on the panel so that you can ask a question or put your comment, whatever you are trying to. Let's see what Sana has to say. Yes, Sana.
Yeah, basically I got confused. Say I work on BRICS economies. So we have 5 countries, right? Brazil, Russia, India, China, South Africa. And for 5 countries, we have a time series data. So it is kind of, it looks like a pool data as per your explanation. But when we see the papers and other things, always the panel data analysis techniques are conducted on that. So could you please?
Yes. Okay, that's a very good question and very pertinent question, and she is correct. And in my own studies, when I am taking this data, I am using panel regression techniques. Now, why we are using this panel the thing, we are using softwares, and generally we are using softwares which are command-based software, because generally people don't know about the computer language, or they do not know Python or JavaScript, etc. And or if people know R, then they can use it. So the issue is, because in softwares there is no distinction between pooled, cross-sectional and panel. This is the difference. That's why we take panel regression, and therefore panel regression or this panel techniques have become very popular, and now these panel techniques are used both for cross-sectional but panel. But technically, if you see, there are some differences, and therefore if you are using your data set in eViews, it will automatically detect the techniques which you have to use for your data. So there is no term of pooled cross-sectional analysis in the eViews. The reason is, one thing, it is very complicated because it is a longer term, and the second thing is that because most of the techniques for panel and pooled cross-section are same, that's why they have not differentiated in the softwares. But theoretically and technically there are differences between these two. Okay, clear? Sana, is it clear to you? You can post your answer here in chat box if the answer is clear to you. Okay. So Maria is posting a comment. Can we apply time series data in qualitative research? It's a very interesting question. What is a qualitative research? Let's take Maria on panel to ask her, what is this qualitative research? Let's take her to the panel, because this is very important for all of us to understand that whether we have some understanding of this qualitative research or not. Yes, Maria, what is qualitative research and what is quantitative research? Yes, Maria, what is qualitative research? When you say, can we apply time series data in qualitative research, what is your meaning by, what do you mean by qualitative research, for example? Your mic is muted, Maria.
1 minute. Now can you hear me,
Yes,
Neil?
yes, yes, yes. Yes.
Ultimately we convert all the qualitative data in quantitative because we need to apply the mathematical model into this. But as far as I know about the qualitative data, when we research on values or attitudes of people, on perceptions, as I comment in the comment box, that I want to know that if I want to confirm that if we want to measure the stress among individual month by month during lockdown, so this is this a time series data? Can we apply time series in this type of data?
Yes, because suppose you take January 2020, you have 10
Yes.
people, okay, but because you will have more people now, you have 10 observations, then it will become pooled cross-sectional. Because you have more number of samples, you will not have
Exactly.
one
I
value
want
for
to know
one
this
time
thing,
period.
that is this a pooled cross section or is this a time series data?
No,
I'm confused between this.
because you have more observations, therefore it will be pooled cross-section. It will not be a time series data, and repetition of sample is there. So you have the feature of cross-section data because the more observations are there, and you have the feature of time series because it is spread across time. So you have January. In January, you have a stress of 10 people. In February, you have a stress of 10 people. So it is a cross-sectional, pooled cross-sectional data. Correct?
Okay. Or as I mentioned, stress level. So stress, it is I think is a qualitative data.
Okay, so this is a very good issue of okay. I'll thank you, Maria, of qualitative and
Thank you, Nirmal.
quantitative data. Sometimes my understanding is quite different from the understanding of others. For me, the difference between qualitative and quantitative research is diminishing day by day. And for people who say that qualitative research exists, I say to them that there is no strict compartmentation between qualitative and quantitative research. And the difference or the gap between these two types of research is just diminishing. And now we have a combination of both. We cannot say that somebody who is doing a research on stress, for example, is doing a qualitative research uh, because he or she is also applying quantitative methods of measuring the stress. Once you measure the stress, it becomes quantitative. So how it is qualitative? And somebody who is doing qualitative part primarily, for example, suppose I'm doing analysis on incomes of the people. Income is measured, and income is measured in quantitative terms, but income also has qualitative aspects. So therefore, we cannot say that somebody is doing a purely quantitative research and somebody else is doing a purely qualitative research. The gap is diminishing day by day. Rather, the other type of classification is much better. Like whether you are doing a descriptive research or a causal research or applied research, those distinctions are much more better than these distinctions. Okay. So Jalaluddin is saying that I'm doing research on financial performance formatting. What are the tools to be used to measure the performance? Now it's a very lengthy topic. We are not going to discuss each one of yours problem which you are facing in analysis. That we can take a separate class or separate arrangement through which we can understand, we can take the issue. So we'll not go into that detail. So I think this is clear for you, the difference between pooled. I'll take Sana again back so that if he has the query related to that, it should be clear to her because it is very pertinent question she has raised. And I'll also show you about what I said to you. I'll share some research paper with you to show to you. So yes, Sana, is it clear to you now? Or you have some more comments?
No, it's absolutely clear now. And that is the point. Yeah, software, I could now understand also that the software doesn't have any distinction between pooled and panel. So it would be
Yes.
the case. Thank you so much.
Yeah, lots of issues are there in software. For example, if you go to EUs, you will never find t-test in the EUs. Okay, you will
Correct.
not find z-test in the EUs. But
Right.
you will find equality of means. So what they are doing is instead of applying t-test and z-test, they're taking all the methods together. And under equality of means, you will find all those things. So if you apply equality of means, then you will get all the results related to T statistic and Z statistic. But specifically, it is not mentioned in EU. So because it is for econometrics, that's why they have these issues and limitation. And their objective is also to make things easy for the people who do not have that much technical information about.
Yeah, exactly. Even in Stata, there is no
Yeah, and
distinction.
standard.
Even if we conduct the pooled OLS, we have commands which are very much like we can apply to both pool and panel. There is no
Yes.
distinction. Right.
Okay. So let's
Thank you.
take up welcome. Okay. So coming back, I don't know why she's. Yes, I'm back. Okay, let's go forward. Now, the most fundamental technique applied very widely with people who use econometrics or try to use econometrics is regression. Somebody is raising hand, so I have to just check out who is raising hand, and then I'll invite them so that we can have the second section. Nobody is raising hand. Okay, so regression, very widely applied by most of the researchers. We are very fond of it. We all apply it. It is very widely used in taking decisions, drawing conclusions. Uh, can anybody tell me the from where regression came, or who basically came up with this technique regression, and for the first time when it was used? Can somebody tell me? It will be very interesting if somebody can throw some light on it. Anybody can raise the hand who can just inform all of us that from where this technique came or some historical background about it, because we all have been applying it. If anybody can tell me, that will be very interesting for all of us. Nobody? Yes, still it is open. Next 5-10 seconds, take more. If you can add anything introductory related to regression, but it should not be the technical thing. It should be something which is not technical about regression. Like for example, there are lots of things people do not talk about. I'll just ask you a question. For example, uh, just raise your hands. How many of you have studied economics? Just raise your hands. Okay. So 5 people have already raised their hands. Now, out of those people who have studied economics, who is confident to talk about Adam Smith? Anybody? I'm lowering all the hands. Now, somebody who can talk about Adam Smith. Yes. Just few things, but very important. Nobody? It's very surprising. Okay, let's take. Nobody is ready to talk about Adam Smith. Okay, Adam Smith is known as dash of economics. Anybody? You can answer in the chat box. So Anshu Singh is saying father. Okay, fine. Now you people are more confident. Now somebody again who can come up and talk a bit more about Adam Smith with me. Yes, anybody can raise the hand very quickly within the next 10 seconds. Talk a bit more about Adam Smith. Next 10 seconds. Nobody? It's quite a disappointing performance of yours. Okay. What was the book written by Adam? The first book written by Adam Smith? So Kiran Kumari has some good thing to add. And he was a Scottish economist, philosopher, and author. So if Kiran Kumari, if you are comfortable, I can take you on panel to talk about it. Should I? Wealth of Nation, everybody is saying Wealth of Nation. Can you write the full title of the book? This is the short form of it. Kiran Kumari is not comfortable to come up on the panel. So the question for you, okay, Mariam Sabrin, Theory of Moral Sentiment, Theory of Absolute Advantage. Okay, so who was Adam Smith? So somebody said that he was an economist, so obviously he was not an economist. Why? Because at that time, economist was not a discipline. So he was not a Scottish economist. He was a Scottish philosopher. Okay, so this is correct that he was a philosopher and he was professor of philosophy in University of Glasgow. This is very important and most of the people know, everybody is answering. Now the second question is, what was the second book of Adam Smith? Or if you can tell, what was the topic of the second book of Adam Smith? Okay, the full name of the book is An Inquiry into the Nature and Causes of Wisdom. What was the second book of Adam Smith? Okay, so this is what we don't know, because we have only focused on his first writing and even people have not read about that writing. So this is a problem with all of us. We should try to know more about this. So the second book was on statistics written by Adam Smith. Okay, now come on back to regression. So regression was given by Francis Galt. And who was he? He was not a statistician. primarily. He was a biologist, and he was the cousin of, this person who Darwin. He was a cousin of Darwin, Charles Darwin. And he used this technique in order to know about the differences in the average height of the people. This is how he started using regression. So regression came not from some statistician primarily or some mathematician, but it came from a biologist who was interested in knowing something, but he applied mathematics to that particular thing. So this is how regression came. And regression works on averages. This is very important for all of us to understand. Regression works on means, arithmetic means. And arithmetic means are not always reliable. They are sometimes misleading. Take the example of arithmetic means. Suppose you have to cross a river. Can you rely on arithmetic mean? So there is a family of 4. And they have to cross a river. So what happened? What they did, they tried to measure the depth of the river on 4 different points, took the average of that, then they took the average of their heights. They started crossing the river because the average of the height of their heights was more than the depth of the river. That was sampling. When they started crossing the river, their youngest child, which is drowned into the river. So that is a mistake, because arithmetic mean is not to be used at this particular point of time in order to measure the river, because they have not relied on standard deviation in addition to that. So this is what we need to know before applying a technique. Now regression is widely used by all of us, but when it comes to econometrics, and you can apply regression as well, but if you are applying regression according to the fundamentals of econometrics, then you have to deal with the finite sample property of ordinary least squares regression. That is the next issue which we are going to talk about. And I have selected that because we people, we all use regression, which is the most widely used tool. And therefore, if you apply it according to econometrics, it will be much more beneficial to all of you. So this is finite sample property of OLS. There are 7 assumptions of regression in econometrics. Without fulfilling those 7 assumptions, if you apply regression, it will not be taken as a dynamic model of regression. So it is a widely used tool in econometric analysis. Its prerequisites are known as finite sample properties or assumptions of regression. Simply, it is known as assumptions of regression, but the technical term in econometrics is finite sample properties of ordinary least squares. Now, there are some researches on application of research. So if you see that there is one research that out of 99 studies which was selected, only 17% of the study discussed the FSP2. Means most of the regression studies do not talk about finite sample properties. They never go for checking the finite sample properties. And because they are not going for checking the finite sample properties, they cannot be relied for forecasting. That's why their models are not used for by other researchers in the developed countries, you can say. And that's why how citation doesn't move. So this is one of the problems with all of us, that when we apply regression as it is, but we do not go for checking the finite sample property. So we are able to publish somehow, but either we are not able to publish in a very reputed journal, or we are not, or even if we are able to publish, we do not get cited for our models. We do get cited for our conclusions, but we do not get cited for our models. And if your models are taken by others, then it is how citation starts going up very rapidly. So this is one of the problems. That's why it is important for us to understand how to apply regression along with finite sample properties. So what are those sample properties? There are 7 properties. They are also known as Gauss-Markov theorems or assumptions. So here we will refer to the FSPs, finite sample parameters properties. The first one is linearity in parameters. Now, what is linearity in regression? People generally understand that linearity of regression is to do with independent variables. No, it has not to do independent variables. So if you have an equation, then in that equation, suppose you have an equation, for example, y equal to beta 0 x plus beta 0 beta 0 x1 plus beta 0 x2. So x1, x2, x3, x4 are considered generally by the people that if x1, x2, x3 are linear in nature, then we say that the model is linear in parameter, which is absolutely wrong. When we say that a regression model is linear, we talk about the parameters, that is coefficient. That is, if coefficients are linear, then we say that the regression model is linear, or we say that linearity in parameters are there. If your coefficients are not linear, then you cannot say that your model is linear, and then you cannot use for forecasting or for drawing inferences in linear terms. And we know human beings generally think in linear terms. We cannot think in the exponential terms. For example, we only think, okay, we think in doubles, triples, 10 times, 20 times. All this is linear. We don't think that, okay, my income will improve by, we say, okay, after 10 years, I believe that my income will improve by 4 times, by 200%, by 500%. But we don't talk about that my income will increase by 2 raised to power x minus 1, where x is equal to e in the next 10 years. We don't talk about in this manner. So for human beings, it is very difficult to talk in non-linear terms. That's why for a simple model, we call it parsimonious model, which is a very simple model to forecast, and for the human beings to understand the forecasting, linearity is selected. But this linearity is not in independent variable. This linearity is in the coefficient with the independent variable. So this is the assumption that the random process, and don't go into these mathematical terms, I'll make it simple for you to understand, follows the linear model, that everything is linear. So whatever is happening within the variable is according to times, where ut, t1 to n is the sequence of errors of distribution. Here n is the number of observation. So we call it that if there is a random process in the error term as well as in the coefficient, then we say that this particular linearity parameter is present in the model, and we will say that, okay, first assumption has been fulfilled. I'll tell you in detail how to go with that. I'll show you the research paper, and I will also forward that research publication of mine, how to test this linearity. Second finite sample property. Now it is becoming called no perfect collinearity between the variables. In the time series, it is particularly very important to check this, that no independent variable is constant, nor a perfect linear combination of other. It allows that the experiment to be correlated. But so it means that your explanatory variables, that is your independent variables, may be correlated, but there is no perfect correlation within the independent variables. So if within your independent variable, suppose you are having a model where you have on one hand GDP, on the other hand you have exports, imports, and then you have you have exchange rate. If suppose the correlation between exports and imports is 1, which is exactly same, then it means that there is perfect collinearity between these two variables. Then you cannot run your regression, because then this assumption is not holding true, and that's why you cannot run your regression. You have to drop that particular variable, and then you have to bring another variable. So this is the second finite sample property. The third finite sample property is zero conditional. In order to properly understand conditional mean, you can see the initial discussion on conditional mean into Gujarati, basics of econometrics. That is very. So conditional mean is that the expected value of a particular sample size with respect to the average of that sample in future. That is the zero conditional. If the conditional mean is 0, then we can go for future analysis and using that regression. Otherwise, again, we have to do some changes. Okay. Its further explanation in simple terms, it means that the variable, random variable, the stochastic variable or the randomness which we had talked about in the last class, must not be correlated with the independent variables or with any past or future variables. Then we have the next, the finite sample property 4 and 5, homoscedasticity, okay, which means that this is an assumption, and the opposite of this assumption is heteroscedasticity, which is a problem that if your sample is not homogeneous, and this homogeneous or homogeneity doesn't mean perfect homogeneity, but if it is somehow acceptable, then we can go with the regression model. Otherwise, we cannot, which means that is conditional on theta, that is the variance of error term, is the same at all levels. So you run some random processes and some test of homoscedasticity, heteroscedasticity test, and if the error terms, the variance of the error terms is same for all time periods in time series data, then you will say that okay, there's homogeneity in this error term functionality, and then you can go for the regression analysis. So some technical, the variance of ut with respect to theta is equal to variance of ut without any condition, etc. Then fifth is no serial correlation or autocorrelation. Now autocorrelation is the correlation between the past and the present values of the same variable. Conditional on theta, the errors in two different time periods. So the past values, for example, GDP to 1991 GDP and 1992 GDP. If there is correlation between 1991 GDP value and 1992 GDP value, then this is a problem, and we'll say that there is a problem of autocorrelation. We have to reduce or just treat that particular problem if we have. Otherwise, again, we cannot draw inferences from our regression model. And the sixth one is the finite sample property 6, which is most widely used by the people in research. And generally people write that normality, they test normality. And they test normality of the data. So I just want to talk about this normality because this is one of the very popular misconceptions. So somebody, if he or she wants to come in, or wants to jump in, and let us know what this normality is and how this normality is used in analysis. Anybody, you can raise your hands. Anybody would like to add what is this normality? Nobody? Okay. So generally, people who are into PhDs, and I'm talking about whatever I have the experience of in my university and other Indian universities, apart from my experience in Russian universities. So the issue is that people generally use normality testing. They have histogram. They use histogram to test normality of their data, and then if it is normal, they start applying regression, and then they check hypothesis with the help of that. So they call it normality testing, that the data is normal. But you will be surprised to know that this type of normality is used only for t-test or other this parametric test. This type of normality is not to be used in regression. In regression, normality means something else. In regression, normality means that the error terms, that the random variables are independent of theta and are independently distributed as normal. So it is not the normality of the variables of the series, no. It is normality of the error term, the random variable. If the random variable is normal, which you can only know after applying regression. If you apply regression, and after applying regression, you get the residual values of the regression. And then through residual values, if you check the residual values for normality with histogram or any other technique, then if it is normal, then it means that your regression model is fulfilling the condition of normality of the error term. This is what finite sample property 6 is. Therefore, all these properties are not to be, assumptions are not to be applied before running the regression. This particular assumption has to be applied after running the regression. Okay. So in the present study, the discussion revolves around FSP 1 and 6, and objective remains to verify the assumptions of raw data. Now, FSP 7, finite sample property 7, is not that much popular under Gauss-Markov theorem. So I have not taken that, and it's not that necessary. So like white noise is there, and it's not that necessary. That's why I have dropped that particular thing. And now the house is open for questions and further discussions. And I'll also show you some research papers to related to that. So first, the house is open for question. You can pose your question. Meanwhile, I'll show you the research paper, which I will also email you, which is regarding the finite sample property. So meanwhile, you can just share your, post your questions over here. I have this here, and we can go here. Okay. So you can say this is one of the publications of mine on specifically on this topic, the macroeconomic variables of India and finite sample properties of OLS under classical assumptions. And here you can see that we have, I have mentioned all the finite sample properties starting from FSP1 to FSP6, and how to check. All the methods are given, conditions, how to apply the condition, and what are the methods for multicollinearity, then what are the methods for zero conditional mean, how to apply, how to equation. I have used a real-time data of Indian economic series to apply and show to the researchers how to do that. What kind of statistics to be used for checking linearity? One of the best statistics to use for checking linearity is wall test statistics, which you can use with normalized restriction parameters. These are the parameters which are normally restricted. So you can read and apply through these techniques. Then variance inflation factors, multicollinearity, White's test, BG serial correlation, and then fundamentally histogram, and you have all the conclusions. Okay, so you have 6, you can see the table 6. You have all 6 finite sample properties. Then you have status, accepted, rejected, 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 accepted, accepted. Now, if you have this kind of complication, you can have 2 methods to go for the regression. One is either you do some transformation so that these 3 becomes accepted and then you can apply the regression. Or if you have 6, for example, and if you have 4 which are accepted, then you can go for it. Though it is not very plausible conclusion, because it is just like concluding in a democracy. So it's not that kind of argumented based conclusion, but you can do so for the ease of doing the analysis and for parsimony of the model. But the best thing is you do some transformation in the data to reach to that position. Now, if you have problem in collinearity, it is easy. You can drop independent variables, add more variables, and you can go on testing, and then you can get the results. So this is what you can do, and this paper I can share it to you. You can pose the questions. So Mohammad Anas has questions. I'll give you 5 minutes so you can pose the question. Meanwhile, I will try to share more panel data regression techniques with you on the research paper so that you can have a look on it. I'll go to that. If I can share it with you. So I have this over here, I will put it over there. We have publications, and I can show you some publications related to. So you want to see the panel data. You can see this panel data analysis. Just a few indications. So we have this panel causality analysis, FDI International Trade, published in Transnational Cooperation by Taylor and Francis, and this is an ABTC listed journal, and Scopus as well as Journal of Science. Let's see why it is. Okay, so if you can see here how to write an empirical paper on econometrics. So that is also what we can do talk about. So you can see all the econometric tools are there. We have panel data, we have equations for panel data, we have data, we have statistics, and how to go for writing an empirical paper. That is also very important. Because you see, this is the Foreign Trade Review, Journal of Indian Institute of Foreign Trade. Again, good journal by Sage. Here also we have applied the sample properties, regression with the finite sample property. So we have lots of publication which we can share with you. You have, if you see another paper on gravity model, you can see one of the models in econometrics is the gravity model. We have 2-3 papers on gravity model. Let's take into consideration, for example, this is a paper gravity model, if I'm not wrong. Okay, this is how to write. So just briefly, if you want to write an econometrics paper, it should be very crispy. Unnecessary things should not be there. You have introduction, then you have review of literature, and then you have conceptual framework. Conceptual framework in econometrics is something different. You try to come up with the concepts of your model. You try to define your parameters, how you have developed your model, what is the theory behind your model. But it's not just about theory, writing theory, it is also writing theory into mathematical terms. Okay, so that is very important. So you have to tell everything about variables, what are the expected symbols of the variables, what are the elasticities, etc. Then you directly go for econometric models and estimation method, how you are going to model, how you are going to label things, what are your criteria, etc. And then you go for the data, and that you discuss the results, and then final conclusion. This is a very simple and brief econometrics paper. And the other things which are not very relevant for the readers to read, you can put it in the appendix, which are technical things. So if they are interested, they can go. Otherwise, they can go on reading it without any interruptions. For example, variable description is there. For example, the stationarity, original stationarity is there, and the transform data is then shown how it got transformed into a different series. Then the data sets are there, then OLS results are there, and then the normality test of white noise is there. White noise is something different. So we can have all these things for you in future. Okay. Now come to the questions. Let's see the questions. So starting from Anas. Anas saying, I'm working on the secondary data and always face the problem with normality. Suppose my data is not normal, so what can I do? Because I can't change the figures as a figure secondary. Sorry, but I didn't get the third property requested. Okay. So first, go back to the third property. He wants to have a question on the third property, that is zero conditional mean. So I told you, in order to understand that, first of all, you need to go to study conditional mean. And what does conditional mean is, we have different samples. In one sample, we have two series, suppose. First 10 observations, second 10 observations. We have a mean of first 10 observation. We have a mean of then second 10 observation. We divide the series into that type. Now we compare all these means. If one mean is conditional on another 10, it means it is somehow related to other. That is the meaning of conditional. If conditional mean is 0, it means within the series there is no condition which is changing the mean of the series. Then we say that that is zero conditional. It is important to tell us the internal dynamics of the series, because it means then that these samples are not somehow correlated within themselves. And then therefore we can use it for drawing inferences properly. Now, if you say you are always having problem with the normality of the data. Now again, if you're talking normality in econometrics terms, it means first you have to apply the regression, and then you have to check about this. But you can go for checking stationarity in econometrics, which is something equal to normality in the normal distribution. Second thing is that you can go for difference to difference data. Then you can difference the data according to the lags. So every time you have a difference, but we don't allow, or we don't accept going to beyond second order differencing. So suppose you have 10 years data, if you difference the data, you will get 9 observations. This is first order difference. You can go second order differential. It will be then 8 observations. So order differential is y minus y upon 1 minus t. So y for 1992 minus y for 1991 will give you 1 observation. So if you go on doing this, you will get first difference. Then with first difference, if you apply the same technique, then you will get second difference. So with first difference data, the probability of normality reduces by around 23%. With second differencing, the probability of normality reduces by next 28%. But if your data set is not having large number of observations, then always there is a problem of. So you should have the more number of data observation you have in your data set, the better it will be to achieve normality. So if you have only 10 observations, it's very difficult to get normality. So you need to have at least 60, 70, 50, at least 40 to 50 observations to have better output of that particular data set. Sana is asking, please recommend a book on panel data analysis except Badi. I mean a book that is best for conceptual understanding and not loaded with the equations only, but includes. So you can take Gujarati by examples, because Gujarati by examples has panel data analysis, and because you want to go with the examples, so you can go for Gujarati with examples. Okay. Okay, any other question in this particular discussion, because we are just close to our time frame. 4:30 was the last time. If you would like to ask questions, next 5 to 10 seconds for you to pose questions. Maria is asking, kindly share your easiest paper so that we can easily understand the basic application and analysis of regression. So all papers are easy once you know econometrics, they are not difficult. But I will send you a paper which is, or you can go to Google Scholar and you can check out my profile. And from there you can, I'll just post my profile of Google Scholar or ResearchGate. And from there you can take my papers and you can read my papers. And even if you have, or in future, if you want to collaborate with me on econometric techniques, you are most welcome. We can share a topic. Just go on. But I have very limited time due to my busy schedule. So it will be quite difficult for me, but I will try to see what I can do for you. So I'm just posting my profile. You can go for my Google profile, or you can go for my Scopus profile or Web of Science profile as well. So this is my Google profile for you on. Okay, I'll give you my Scopus profile also. I think when you all receive my emails, you must be receiving that. Okay, any other question? Please post. I'm just posting that. So I'll just so I have posted my whole signature for you, and along with signature, all the things are mentioned. You can take from here. Okay, Google Scholar profile, also profile, Web of Science, researcher ID is there, and Scopus ID is also there. You can go with that. And now, any questions? I think no questions are there. Now, few people can raise their hands to come, and because this is the last session of workshop, the workshop will end with that. So I want your feedbacks today, live feedback. Yesterday, only 10 people responded to the feedback form, which was quite disappointing for me, because in order to improve our interaction, I want feedback. So live feedback I want before we end the session from at least 10 to 15 people. Participants, so please volunteer, raise your hand. I will invite you. Just give your feedbacks in 1, 2, 3 minutes, whatever you want. This is your time. Your criticisms, your suggestions, areas of improvements, etc., so that I may use these feedbacks to arrange more such types of workshop for you in the future. And hopefully the certificates, you will be delivered the certificates most probably within 2 days. Okay, I'll take extra effort to send you certificates within 2 days. Yes, so please raise your hands to come up and give your suggestions, criticisms, and so that we may have more such sessions in the future. I'm also posting my mobile number for your future reference. Okay, but there is a disclaimer: don't call me after means 5 or 6 p.m. because generally I prefer I go to eat sleep very early in 9:30, 9:30 or 10. So I don't want disturbance after 5 or 6 p.m. In office hours, you just do me a call or you just send me a WhatsApp message. That is good. Yes, please volunteer yourself. Please raise your hand so that I may uh, bring you in. Okay, I'll just select on my own then. Uh, Anshu Singh, are you comfortable to talk about? Anshu Singh, you can come and just give your suggestions. Should I invite you? Are you comfortable? Okay. So I'm promoting Anshu to the panel. I'll promote more people so that we can have. I'll promote more people. I'll promote Maria also. I'll promote Aksanjum. Let's promote her. Let's promote. We have some faculty members. So let's promote her. Him. Faisal Khan, let's promote Faisal, and more will promote because this is the last day and I will unmute everybody. So starting from Anshu Singh, yes, your suggestions and comments on this workshop.
Sir, it was very informative webinar workshop. So I will suggest that time should be taken by you. It would be more because we want to gather more information from you.
Okay. Any other areas of improvement for the future? That the time frame was means it was comfortable for you to join for 1.5 hours.
Yes, sir, it was. It was
Okay.
comfortable for us to join.
Okay. Okay. Thank you. Mari Ansari, yes,
Thank you,
your
sir.
comments.
Ji Nair bhai. I want to say that it was so productive and so fruitful session for us, and you were so smooth and fluent with your presentation. Yesterday I was having a chat with Anas that this was the first so productive workshop during the lockdown. We have so many, we participated in so many workshop and webinar, but this was the best, I can say, and
Okay. Thank you. Thank you.
expecting more such type of workshop from you. And I want it to be more longer from 2 days. 2 days much lesser for this type of topic.
Actually, my past experiences, concentration is a problem for all of us. And
Yes.
beyond 2-3 days, it's very difficult for people to concentrate. You need to have that kind of motivation to learn these things. And I don't know about motivation of the people, but it's very difficult for the people. Look, for example, you see right now, in yesterday and today, we had not more than 50 attendees. I mean, yesterday,
Oh.
initially, we had 78. But today we had 45 to 50. Now you imagine I had to reject applications of around 70 people because only first 100 were invited. But this is disappointing that in first 100, 30 to 40% people are absent. Now they have actually taken the capacity of others who are really interested. So these things are there. So, but I will consider to have more such workshop. Thank you, Maria. Okay.
Thank you, Nirvai.
Okay. Aksa Anjum, your comments, please.
Assalamualaikum, sir. Well, it was very interesting and informative workshop. Concepts are also clear to me now, and also the books you recommended going to help me out. And inshallah, I would welcome to be a part of your upcoming workshops. Thank you, sir.
Inshallah. Thank you. Thank you. Okay. Dr. Noshirma, would you like to add something? Dr. Noshirma, would you like to add something? I think he's not present. He's not getting. Okay, Faisal Khan, would you like to add something? Faisal Khan, would you like to add something? Okay, Asim Imtiaz, would you like to add something? Give your suggestions, comments. We have Dr. Mohammad Sajid. Let's take him. Okay. Dr. Mohammad Sadiq, you would like to give your suggestions and comments on it?
Yes.
Yes,
Yes,
please.
ma'am.
Yes, Ji, Sadiq bhai, yes, your comments, please.
I have attended all the sessions from yesterday to today. It was a nice interaction and wonderful experience. As a expert, as a researcher from tourism fraternity, I would like to suggest to you that the workshop should be more focused on the area of tourism and hospitality management.
Okay, okay, thank you, noted. Then Shujat, would you like to add something?
Yes, nearby.
Yes.
Yes, it was very good experience. But the time was good. The time you allotted, like 1.5 hours, that was good. You had a smooth speed, that was nice. But I want you to do more workshops on like tests, like on T test, Z test, and the inferences you draw from it. Because in normal workshops, people don't usually talk about them. They just get into these like they talk about the model, they say this the hypothesis is accepted, rejected, but they don't actually get into these things. So
Okay.
and it can be done in 2-3 days, as you said. It is not suggestive to do a longer workshop. So I think it can be done in 2-3 days, and probably you'll be the best person to do it.
Okay, thank you, Shujat, for your suggestions. Kamlesh Chandra Sahab, your comments, if you would like to give some. Yes, Kamlesh Chandra Sahab.
Yeah, sir, it was really nice hearing you from last 2 days. And I think we should have more such workshops in future also, because there are a lot of topics which we need clarification in research area. So if you have time in future, you just conduct a few more and invite us for your workshops.
Okay, okay. Thank you so much for the suggestion, sir. Then Hemant sir. Hemant Sahab, your
Yes,
comments.
sir. Good afternoon, all of you. It was a nice experience to interact with you, sir. And
Thank you,
I
thank
would
you.
like to know more about tests like t-test, z-test, all parametric, non-parametric, using SPSS and other software as well. So please
Okay.
conduct some workshops on SPSS or other software, so that it can be helpful for all the fraternity members.
Okay. Thank you. Thank you. The
Once
suggestion
again,
is good, but
thank you very much. Once
thank you.
again, thank you very much for organizing such kind of
Thank you.
intellectual
Thank you. The
workshops.
suggestion is good, and I personally know how to use SPSS, but I'm not an expert in SPSS. So that is not my cup of tea. So I'll ask somebody else, or if somebody else can take XPSS, because I invested my whole research means time frame to econometrics only. So I only go with Python and EVUs. But I'll put up this in the department, and the department can organize such workshop with respect to SPSS. Thank you,
Yes,
Hemant Saab, for your comment.
because it is a basic level of understanding to all research scholars, like SPSS, how to conduct tests and how to uh, uh, report the outcome and all. So it will be
Yes.
helpful. AMU will organize, a big institution will organize such kind of intellectual workshop.
Yes, yes. Thank you, Hemant Saab. Thank you.
Thank you.
Okay, Mohammad Munif, your suggestions and comments. Mohammad Munif, can you hear me? I think he is out. Okay. Sana, your comments please in the last session.
Yeah. First of all, I can't thank you enough for the informative sessions you just delivered. And yes, I would like to divide my feedback into two sections: the three best things and the three suggestions. First, the three best things. Number one, I have attended many webinars during this lockdown, but I haven't seen such an interactive one before. Right, the way you engaged us all, that was really appreciable. Number two, like an econometrics workshop, which is usually loaded with jargons only. This was not like that. You made the concepts very clear to us and in a very easy and simple fashion. And number three, the delivery is exceptional. Like appropriate pauses wherever the pause was needed. We need not to tell you to lower down your speed or increase it, or make something clear or repeat something too often. Right, so that is really appreciable. And now the three suggestions, please. That is, and firstly, keeping the time duration same, we should increase the number of days for future workshops, which we would request you to conduct, please. Yes, because this is a very vast field. I know it cannot be covered even in month or 2 months time, and you are very right in saying that we cannot have so many days and all. But yes,
because that becomes monotonous. I have the experience of that. Means not. I have personally never gone to attend a 10 days workshop anywhere in because I know the limitation of our brains and our concentration, and we live in a world which is quite distracting.
Yeah, but one point I would make here: when we see a resource person like you, we would like to benefit as much as we can. So please, it is a request to increase the number of days.
Yeah, right. That's correct. That we should have more section. I will look into that matter. But my personal observation is that we are living in times when we are more distracted than concentrated, and the attention span has also gone down.
Right.
How every one of us, whenever we see a YouTube video, if it is 5 minutes long, nobody watches it. Okay, we just try to just go fast forward it and see what actually it is about. So there's some impact on our this attention span. So this is quite a problem. So I always try to incorporate these realistic issues in my workshop. That's why I don't want them. But the suggestions are good and try to incorporate in the future workshops. Okay. Thank you, Savannah, so much. Then Saleha Javed, would you like to add something? Saleha Javed, would you like to add something? I think she's not ready to add something. Talha Kamal, yes, your comments, please. Talha, would you like to add something? Okay, let's go to Zafar Iqbal. Zafar, would you like to add something? Zafar, would you like to add something related to suggestion for future workshop or your feedback on this workshop?
No, sir. No, not at all. It was very nice.
Okay. Okay, Faisal Khan, would you like to add something? Faisal, are you there? Would you like to add something?
Can you hear me?
Yes, yes, I can hear you. Please, everybody can hear you.
Workshop on the basis of econometrics. I would like to suggest another workshop on uses of EVUs.
Okay.
And thank you for sharing your wonderful experience. Thank you.
Let's take 2 more people if they can add, and then we will end. Let's take also Mubashir Majid Saab. Yesterday also he gave us very important suggestions, and then we will end the workshop. Okay, Mohammad Munir, would you like to add something? Okay, then Mayuri, would you like to add something? Oh, she's not ready. Okay, Mubashir Saab, would you like to add something as your feedback for the workshop or future workshop? Mubashir Saab, can you hear me? Okay, I think there's some problem. Okay, no issues with this. We end this workshop, and I hope that you all uh, will be using this set of information. I should not call it knowledge something different, but this set of information which we have shared. You can use it in future. You may get motivated to learn on your own, to study, and with the help of that, you can then apply those things. And you will be in touch in future for such workshop. And anytime you can have access to communicate with me. But due to the paucity of time, it's very difficult for me to reply each and every email, though I try my best. So that will be one thing which I cannot assure you, I cannot promise about you, but I'll try to be connected. What can be another strategy for all of us is that we can work together on different projects. This is one strategy through which we can learn. So if suppose we are a group now of suppose 30-40 people who have studied economics or who have interest in economics, we can divide ourselves into a group of 4 or 5, or we can just work together to write research papers applying econometrics. So if we have 4 or 5 authors in one research paper, we can easily share the different portions, apply econometrics technique, and when we can try to publish in reputed journals. This is one thing which I would uh, ask all of you to see towards, and through this we can have more collaboration, and that can have some fruitful results in the near future. So we can have each one of us can have if we divide our group into team of 4 suppose, and we have suppose 5 teams already, then in the end of 6 months we can have one paper for each one of us, and then we can publish it. And in a reputed journal it takes around 1 year to get published. So in 1.5 years we all can have one paper each, which is ABTC or Scopus or Web of Science journal with reputed publishers like Sage, Taylor & Francis, Elsevier, or Emerald. So thank you so much for participating. I wish all of you good luck, and from my portion, I am very thankful for all of you to participate. All of you are present, appreciating all of the things, and being patiently hearing everything, and then also giving your suggestions. Thank you so much. Have a nice day, nice month, and stay safe. Thank you.